Hi, folks. I welcome you all. My name is Chirantan, and I work as a data scientist with Boston Institute of Analytics. Uh, so, today's lecture is going to be about statistics and why is statistics important for data science. Before starting off with that, let me tell you from my experience itself, statistics is a very important part and forms a foundation of whatever analysis or whatever field that you get in. So statistics forms the very core, okay, of data science. Before starting off with that, we have to understand what exactly is statistics and why do we even need statistics, okay? Firstly, statistics is a subject area of deriving knowledge from the data, okay? Let me repeat. It's deriving knowledge from the data, okay? For example, if you have 10 million rows, if you have 60 million rows regarding any data set, regarding whether it's manufacturing, retail, finance, so on and so forth, you have good amount of data, you have loads and loads of data, but how do I even derive knowledge from the data? Okay, what do I even do with that data? Okay, what do I even do with that data? So for that we need statistics. So statistics as a subject is very broad, okay? It's a very broad subject, and this subject is classified into two parts, okay? Firstly, there is descriptive statistics and the other is inferential statistics, okay? Descriptive statistics and inferential statistics. When I talk about descriptive statistics is only about collecting the data, it is only about organizing the data, okay? For example, we have census, okay? Census happens every 10 years in India, okay? So it happened in 2001, it happened in 11, it happened in 21, it happened in 31. It will now happen in 31, okay? And recently, a few days back, we saw this news that we as a world population have crossed the target of 8 billion, okay? So I have just collected the data, I have organized the data. You have seen that the government employees, they come to your door, they ask for your government documents, and then they make a note. So they just collect the data and organize the data. So what will happen if I just have a pile of data? Okay, it has been just stacked in the offices for years and years, and I don't do anything with that data. What will happen? I just collected the data and I organized it. That's it. That is the entire thing that I've done. And that is when inferential statistics comes into picture. By the name itself, we can understand it is talking about inference or something called as conclusion, okay? So here I will collect the data, I'll organize the data, and I'll also analyze the data, and I'll land up on a conclusion, okay? For example, if I have this pile of census data, I collected it, I organized it, then I decided to analyze and conclude that, for example, hey, the sex ratio in Haryana seems to be imbalanced. The education rate in Kerala is much higher. The unemployment in West Bengal is at its peak, so on and so forth. Okay, for example, the sex ratio in Rajasthan seems to be different as compared to the last decade, so on and so forth. So how do I land up on that conclusion is with the help of inferential analytics. Okay, so again, we need statistical analysis, we need statistics as a subject to derive the knowledge from the data. Then we divide it into descriptive analytics and inferential analytics. In descriptive, I have collected the data, I organized the data. In inferential, I collected, I organized, I analyzed, and I landed up on a conclusion. Okay. The entire game of statistics, okay, the entire game of statistics lies in only two parts. Okay. One is population, and the other is sample. Okay. Population is given by capital N, sample is given by small n. These are the notations, okay? So whenever someone is talking about capital N, you have to understand that they are talking about population as a whole, okay? And whenever someone is talking about small n, they are talking about just a sample, okay? For example, okay, every one of us had days, we had all ill days, yeah. The days when we were hospitalized, we were not keeping well, so on and so forth. So we had gone to a pathology lab, okay, and they took a blood sample out of our body, okay. This blood sample is nothing but small n, okay, and the entire human blood is capital N. Why do I need to take this sample out of the population is to understand the behavior of that population. Okay, so when I take that sample out of the population, it tells me how does my entire population behaves. Okay, for example, blood test. uh, the pathologist will just take around 5 ml of blood from your body, and then then they will gauge you on different attributes, for example CBC, hemoglobin, WBC, RBC, so on and so forth, the cell growth, so on and so forth. So by just deriving a sample, I have understood how the human blood or the population here is acting, and then we do the diagnosis. Okay, or they have landed upon a conclusion. Okay, so this is also a part of, yeah, uh, inferential statistics. Okay, so please note capital N and small n. Okay, and in the industry you can find hell lot of examples when it's talking about population, when it's talking about samples, so on and so forth. Now I want to we have learned about statistics. Okay, we also discussed something about population and about sample. Okay, but when I want to take a sample out of a population to understand the behavior of the population, I do something called as a sampling technique. Okay, and these sampling techniques are usually deployed in the in the area of research, whatever research you are in, to understand that particular population, to do particular analysis. Now there are many such sampling techniques. Okay, one sampling technique I would like to discuss here, and it's probably one of the most important sampling techniques, is simple random sampling. Okay, firstly, by the name itself we have understood that it's a sampling technique. Secondly, the most important part is about random. Okay, so firstly, we have understood that the samples have been picked up randomly here. Okay, in this sampling technique the samplings have been picked up randomly. Now here every sample that is chosen from the population, okay, every single sample that is chosen from the population, let's say we have population n and we have n1, n2, n3 up to n99 samples. Okay, here every sample that is has equal opportunity of being chosen. Okay, every sample has equal opportunity of being chosen to understand the behavior of the population. Okay, and that is what simple random sampling means. For example, let me give you a very small example. Okay, India is, people call India as land of festivals. I call India as a land of elections. Okay, and every now and then you can see that there are exit polls on television. Okay, for example, let's say if the result of election is going to be out on 7th, you can see that the news channels have already started us giving us exit polls on 31st. Okay, now how did they come up with that number? Okay, for example, news channels, how did they come up with number? For example, this party will get this many seats, that party will get that many seats, so on and so forth. How did they land up on that exit poll? Simple, they deployed something called as simple random sampling. Okay, so what the journalist will do now, the journalist will go in that area. For example, if we are in the city of Mumbai, they will go to a particular area and then they will randomly select samples. Okay, they will randomly talk to a taxi driver, to a college going student, to a housemaker, to someone going, some gentleman going to the office, an auto rickshaw driver, a businessman, so on and so forth. So they'll randomly select the data, and then they will ask them the questions that, hey, what do you think, who will win? Hey, what do you think, who will win? Who you think will lose? Who you think had the maximum impact in the last 5 years? They collect a number of samples, they collect a sample of reviews. Okay, they deploy this technique of simple random sampling, and that is how we get exit polls. Okay, this is the basic funda of exit polls, and the entire media industry across the globe, okay, whether it's TV, whether it's magazine, whether it's YouTube news channels, whether it's anything, okay, print publications, media publication, digital publication, everyone works in simple random sampling. Okay, so again, let me just give you a short brief. Simple random sampling, we are doing sampling here. The samples have been selected at random. Okay, and every single sample has equal opportunity or equal chance of being selected to understand the nature of the population. Okay, second type of sampling that I would like to talk here is or I would like to discuss here is something called as systematic sampling. Okay, Folks, firstly we discussed about a random sampling, okay? And now I want to talk about systematic sampling, okay? What exactly is a systematic sampling, okay? Firstly, this is not random in nature, okay? My research area here is very much fixed, okay? I have a fixed question. For example, I want to understand the behavior of every 10th passenger coming out of an airport on the weekend, okay? Let me tell you, I have a very fixed research query or a research question, okay, that I want to understand the behavior of every 10th passenger, okay, of every 10th passenger coming out of the airport, yeah, on a weekend, okay. So what is fixed here? I've said that, hey, the 10th passenger or the 10th number remains fixed regardless of the gender. They can be male, they can be female. It's okay. Okay. Firstly, 10th passenger coming out of the airport, and again it should be a weekend. Okay. So my research area is very much fixed, and that is when I decided to apply systematic sampling. Okay. Systematic sampling is being basically used when your research query is very much fixed. Okay. Or for example, if you want to understand if you want to understand how milk is being produced in tier 3 cities of the most underdeveloped states, I've given you a research query, so you know that firstly it's you have to understand about the milk production. Secondly, it has to be tier 3 cities, and again tier 3 cities of not the flourished states but the underdeveloped states. Okay, and that is when, and these are the areas when you will be applying the technique of systematic sampling. Okay, the third sampling that I would like to discuss here is something called as a convenience sampling. Okay, convenience sampling is a type of sampling technique where only the experts are involved. Okay, so for example, if I want to understand what is going to be the coal output in the year 2023 from North India, okay, I am not going to go on the roads and ask a layman that, hey, what do you think is going to be the output of the coal in 2023 from North India, right? I have to talk to people who are experts or in metallurgy, who understand how the coal mines work, or basically remotely, or probably not even remotely, they are specialized in that particular area. Okay, for example, or economists. Okay, for example, if I want to discuss about the unemployment, if I want to discuss about consumer price index, I want to discuss about fuel price, so on and so forth, economists are the right people with whom I should discuss, right? And they are the one who are going to be the decision makers, who are going to be the policy makers, so on and so forth. And that is when convenience sampling comes into picture. Or for example, a platform, for example, if there is an OTT platform and that OTT platform wants to build a recommendation engine just like Netflix or Amazon Prime, they're going to get in touch with the data scientists and the software engineers in the company, because they are the experts in that field, and that is where convenience sampling comes into picture. Okay, so three types of sampling, guys. There are many types of samplings, but three most important types of samplings that we have here: simple random sampling, media entertainment, systematic sampling where the research query is fixed, 10th passenger coming out of the airport on a weekend, and convenience sampling. Okay, for example, understanding unemployment in the country, understanding coal production, or understanding, for example, understanding of automobile sector, okay, in the next 5 years. Yeah, those are the basic sampling techniques that we have. Okay, now let's go to some school level basic statistics. Okay, just some absolutely school level basic statistics. I'm pretty much sure everyone has an idea about these concepts. These are mean, median, and mode. Yeah, just a quick brush up. Mean is nothing but an average. Okay, median is nothing but the centermost value. Okay, centermost value of my data set. And mode is nothing but the most frequent elements in my data set. Okay, what is mean is basically the average that I get. Okay, but why is average considered to be the most important part? Okay, when we are doing some statistical analysis, why am I, for example, you have heard about average order value, okay, for someone like Zomato or e-commerce people. Yeah, the basket size, okay, it's called as AOV, average order value. Okay, why is average order value important? Why is average sales price important? Why is average stock price important. Okay, why am I taking average? Okay, and why am I not focusing on median order value or median sales price or median stock price? Now that's because average is always considered to be a benchmark, okay, in the industry to be compared against. Average of anything, okay, average of X. This X can be anything, okay, order value, stock price, sales price, ticket price, so on and so forth. That is, average is always considered as a benchmark. Okay, so for example, if there is a bank, okay, and bank has multiple products. Bank has a credit card, they have a debit card, they have some citizenship card, they have some EMI card, so on and so forth. They have so many products, tangible products that I'm talking about. Okay, now for example, if someone wants to understand what are the credit card recovery rate, okay, what is the credit card recovery rate, okay, in this particular quarter, then that will be compared to what was the average recovery rate quarter in the last year. Okay, so average is always considered as a benchmark, or average stock price. Okay, for example, if it is Nifty 50, okay, these are the 50 stocks, so we have an average price of those 50 stocks. So in order to understand, in for example, if in quarter 2, okay, the average Nifty 50 price was this much, this will be compared to what was the quarter 2 average Nifty 50 price in the last year, 2021 versus 2022. And that is the reason mean or average are always considered to be a benchmark, okay, and not the median. Talking about median, yes, is the centermost value in the data, okay, in the data set. Just to have a better clarity, when you have odd numbers in your data, set, you always take the centermost value. Okay, because when you select the centermost value, the number of values on the left and the number of values on the right both stays, they are always equal. But at the same time, when there are even number of data set, what do? I take the middle two values, okay, I take the centermost two values, divide that by 2, and the value that I get is nothing but a median. Okay, again, let me repeat it. When we have odd values, I'll take the centermost value because the values on the left and the right will remain the same. When I'm talking about even values in the data set, I'll take the two centermost values, divide them by 2, and that is nothing but my median. And mode is nothing. Mode is just basically the most frequent elements in your data set. Yeah, it is pretty much plain and simple. Yeah, all right. So this is mean, that's median, and that's mode. Okay. Now I would like to discuss the concept of bell curve, okay, which is also called as normal distribution, yeah, or which is also called as a Gaussian distribution. Okay. Now there are two types of distribution in statistics that we deal around with. Okay. Firstly, there's a bell curve there's a bell curve which is also called as a normal distribution or a Gaussian distribution, and then there is a standard normal distribution. Okay. Why is it called a bell curve? Okay, I'm sure this kind of graph structure, everyone, we have seen this kind of bell structure, this type of graph structure in our lives. Okay, bell curve firstly looks like a bell, okay, and that is the reason it's called a bell curve. Normal distribution or a Gaussian distribution. Normal distribution because it is normally distributed. Gaussian distribution is because statisticians love to call it Gaussian distribution. They like to make things complex. Okay. In Gaussian distribution, I have to find the mean and I have to find the standard deviation as well. Okay. The values of mean and standard deviation are not given, but when it comes to standard normal distribution, the value of mean, okay, mean is nothing but the central region. Okay, this central region, mean is going to be 0 and standard deviation is going to be 1. Okay, please remember, when it is standard normal distribution, your mean is always 0 and your standard deviation is always 1. But before even starting with that, we have to understand what exactly is a standard deviation, okay, and what exactly is variance. Okay, collectively it is called as modes of dispersion. Okay, And these are some of the most important fundamentals in the area of statistics. Okay, very easy to understand, but yet super important metrics to track when when you're working on your data analysis or when you're working on your research analysis, whatever it is. Firstly, there are modes of dispersion. What do I understand by dispersion? Dispersion is nothing but being dispersed, okay, or being scattered, okay. Similarly, if I want to understand the scatterness of my data or the scatterness of my distribution, I take two important metrics into consideration, and that is standard deviation, and then there's variance. Okay. Let us start off with variance. What exactly is variance? Okay. Variance just tells me how spread my data is. Okay, how spread my data is with respect to mean. For example, we have seen that the mean is the central region of the particular distribution. Okay, not the centermost value but the central region. Okay, with respect to mean, I want to understand how my data is plotted, okay, or how is it scattered. For example, if I have X column, if I have Y column, and then I have certain values, okay, and then I decided to plot those values on an XY graph. Okay, it's a 2D plane. Yeah, so I want to understand how data is scattered, okay, or how data is spread with respect to mean along the distribution, and that is nothing but called as variance. So it's usually said that higher the variance, better is the spread and better is the analysis. Now why that? It means that whenever I have good variance or whenever my data is spread good across the mean, I get more values in the central region. And when I get more values in the central region, I can better understand the behavior of my data. I can better model my data. I can better analyze my data. Okay. And that is the reason we say that the variance should be high in order to understand good or to better model my data. Okay. Then I want to talk about something called the standard deviation, which is given by sigma. Okay. Please note, variance is given by sigma square and standard deviation is given by sigma. Deviation, it talks about something deviating. Okay. Now this deviation has to be with respect to mean. Okay. Standard deviation only tells me that with respect to mean, where does my data point lie? Okay. Firstly, these are the standard deviations. Okay, there's a difference of one standard deviation. Yeah, now I want to understand where does my data point lie. For example, if I have X data point lies here. Standard deviation tells me exactly where does my data point lie with respect to mean. Okay, so if my data point lies somewhere here, what will I say? My data point lies within two standard deviations right to the mean. Okay, my data point lies two standard deviations with respect to mean. Okay, so again, standard deviation, what does it tell me? Standard deviation will tell me with respect to mean, where does the data point lie. Okay, that is it. That is the whole funda of standard deviation. Okay, nothing else, nothing more. Okay, so it is just again variance, standard deviation, variance given by sigma square, standard deviation given by sigma. This will tell me how spread my data is, and once I know how spread my data is, I want to understand the standard deviation. Standard deviation will tell me where does the data point lie, okay, with respect to mean. Okay, so that is very much the very first lecture on the basics of statistics. Okay, I'd like to thank you all for joining in for the course, and we'll keep uploading videos every week. Thank you so much for attending, guys. Thank you so much.